So as you can see, this motor, which was taken out of a Samsung ice maker, the one with the flex tray, is turning counterclockwise here. And I got the red hooked up to the red. And I'm going to show you if we reverse polarity, what's going to happen. Alright, now reverse polarity. So the red's hooked up to the white now. And a reverse direction. Now in contrast, this fan, which is a 24 volt, I don't know, probably computer fan, you can see it's turning clockwise. I'm just putting some voltage on it right now. We're going to see when I got it in the standard polarity here, red to red. We're going to see what happens when we reverse polarity on this fan motor. Okay, as you can see, I reverse polarity here, black is to red, and we got nothing. It's drawing about 110 milliamps, but no movement. And even when I try to kick the voltage up to from 10, 12, it's just, I'm going to fry the motor if I keep going. So we can see how these two motors are definitely not acting in the same manner. This one we put voltage in the standard polarity or reverse polarity and it'll change direction, and this one, that doesn't happen. And the answer to the question of why that doesn't happen, you can kind of see in here. You can see, and Walter has a video on this as well. See, there's a little PCB in here. I'm going to open that up. This is a good fan. I'm going to trash it though. Alright, so here's the fan blade. We got a magnet in here, and that is the rotor. Also have a bit of a, oops, let that focus. There we go. A little bit of magnet also here on the coils. There's actually two sets of coils. These two are wired together, so that's actually one coil, and then these two are another coil. Now, the answer to why you can't just hook this up backwards is, if you take a look, there's not much here on this PCB. Not on the front or on the back. There's really no components except for that guy right there. I'm just gonna try. I'm not gonna be able to zoom in on that thing. You're gonna have to take my word for it. It is a HA266A. That's what's written on it. And what it is it's an integrated IC. Pin 1 is VCC, pin 4 on the right is ground, and you can put between 4 volts to 28 volts on the chip. That's what the chip is rated at. That's not necessarily what the motor is rated at. And it has inside it a diode for the supply, and that's to protect the chip if you do put negative voltage across it, so that it won't harm the chip. Okay. Also has a comparator inside, and that's a little op amp. Also has a couple of Zener diodes in there, and it has overcurrent protection, just as well as over voltage protection. And what pins 2 and 3 do they're the outputs for the coils, and note the two coils, this one and this one, are never on at the same time. They alternate, one, then the next, then the next, then the next. And so that's part of the job of this chip. Is it's also a Hall sensor, and so it will sense the rotor and then output on either the 2 or the 3 a high or a low. So that's kind of the long and the short on this thing. And yeah, so if you have any questions, just let me know.